Hello, hi everyone, welcome back to the channel. So, in the binary search series, we'll be solving this problem array division in this video. So, till now, I'm assuming that you have the basic understanding of how binary search work. How do we perform the binary search over a search space or on an answer? So, let's read the problem statement. So in this problem we are given an array containing n positive integers, and our task is to divide the array into k subarrays such that the maximum sum in the subarray is as small as possible. Fine, so we divide the array into k subarrays. Now we sum them up, and what we want to do in this problem is to minimize the maximum sum out of all those sums. That's what we want to do in this problem. So observe that whenever we encounter a problem in which we have to maximize answer or minimize answer, and given some constraints like minimize this, so in these kind of problems try to think about binary search or dynamic programming. So these kind of problems are solvable. These kind of problems are most probably solvable by binary search or dynamic programming. So just think about binary search whenever you encounter this kind of statement where we have to maximize or minimize the answer given some conditions. Like in this problem we have to minimize the maximum sum out of all the sums of the subarrays. So let's better understand the problem statement using an example. So here we have our example. In the example we are given an array containing 5 integers while we have to divide this array into 3 subarrays. Can we divide the array into subarrays with less than k? Yes, but this is of no use because we want to divide the given array into maximum number of subarrays. Why? Because we want to minimize the sum of those subarrays, and this is only possible if we have a minimum number of elements in each subarray, and that is only possible if we divide the given array into maximum number of subarrays. Fine, so that's the idea. So let's try to divide this array. So let's try to divide this array into 3 subarrays. One of the partition can be club these two, and then rest we have 5. This is going to give me the sums as 6 7 6 10 and 5. Let's take another partition, club these two, then keep 7 here, then club 3 and 5. This is going to give me 6 7 8. So what is the maximum sum here? It is 10. What is the maximum sum in this partition? It is 8. So let's try another one. Is it beneficial to club these 3 elements? No, because it would give me 7 plus 4, which is 11, plus 2 13. So no use. Can we club these 2 elements? No, because 7 plus 4 is 11, which is greater than these elements. That means this is the minimum sum which we can obtain by optimally dividing the given array into k subarrays. So how do we divide it? We club first 2 elements together, then we club the next element into the second subarray, and then we put the rest of the elements 3 and 5 into the third subarrays. So in this fashion we'll have 6 7 and 8, while the maximum sum is 8, and that's the answer. So the answer for this test case is 8. How do we solve this problem? What is the intuition to solve this problem? Let's see that. Okay, so observe that what do we want to do is to minimize the maximum sum. Okay, so we want to minimize the maximum sum. So what is our answer? If we divide the given array of n elements into k subarrays, then the maximum sum that we obtain would be our answer. Let's say it is represented by ans. answer. Now for any partition, this is going to store the maximum of sum of all the subarrays. The answer is going to store the maximum of so this is going to store the maximum of sums of all the subarrays. Now we want to minimize this number. That means this is the variable, or this is the answer on which we want to perform the binary search. Now what is the search space for this answer? The minimum what can be the minimum answer, what can be the minimum sum that we can have? The minimum sum can be 1 because we are given positive integers. So since positive integers also includes 0, that means the minimum sum can be 0, because let's say we have an array where we contain 0 zeros like this, or a single 0, so we club them together and we get the sum 0. So this becomes the maximum sum in some case. So that is the minimum sum that we can obtain. What can be the maximum sum? The maximum sum can be the sum of all the elements in the array, because let's say k is 1 for some typical test case. In that case we just sum all the elements, because we can't divide the array anywhere. So the maximum sum would be 2 plus 4 plus 7, 13 plus 13, 16, 5 would be 21. So this is the minimum, this is the maximum. Fine. And we just want and our answer lies in this range. So this answer is basically monotonic. Fine. So if we enlist all the possible answers, we can list like this: 0, 1, 2, 3, 4, 21. So this is the range of our answer. Our answer starts from 0, it can go up to 21, and the answer lies in this range only. And we want to find the very first integer from the left side, where we can divide the given array into k subarrays, and that integer is the maximum sum. That's what we want. Let's say we get 4, then if we can divide this array into k subarrays such that the maximum sum out of all those subarrays is 4, and we can't go lesser than 4, we can't have a sum which is less than 4, so 4 would be the answer. So this is monotonic, integers are increasing, and we just have to perform the binary search. So we put a pointer low at 0, we put a pointer high, we put a pointer low at 0, we put a pointer high at 21, and we perform the binary search, the usual binary search over the answer. That's all. Pick the middle element, pick the middle element, let's say x. Now go to the array, divide this array into k subarrays such that the sums do not exceed x. If we can do so, if we are able to do so, we can divide the given array into k subarrays such that the sum of those subarrays does not exceed x. Then that means x is a valid answer. It doesn't mean that this is the actual answer. It is a valid answer. If x is the valid answer, let's say the x lies here, then we want the minimum integer, so the answer will lie from 0 till this x, from low till this x. So the high is reinitialized to this x. Now the answer range is reduced to this new range. Fine. Otherwise, if we can't find a subarray, if we have a subarray while we divide the given array into k subarrays which has a sum greater than x, then that means this x is not a valid maximum sum that we have guessed here. So in that case, the range would be reduced to mid. So low will be initialized to x plus 1, low will be initialized to x plus 1, while the high will be same. That is, the high, while the high stays the same. So the range goes from x plus 1 to high. That means our answer lies in this range. The minimum integer, which is the maximum sum of all the subarrays, all the k subarrays in which we can divide this array. That's the idea. So I hope you are getting where we are going. Let's try to implement the solution. So this is the implementation. This is a minimize maximum sum function which takes in this array integer k, and we have an integer low, we have an integer high. So this basically specifies the range in which we want to search our answer, while this is the answer which actually stores that integer or the maximum sum of the subarrays. Fine. Or in other words, the minimum of all the maximum sums, the minimized maximum sum if we divide the array into k subarrays. So let's calculate the length of the array, and let's calculate the right boundary. The right boundary would be the sum of all the integers given in the array, because in the worst case we may have, because there can be a case when we have only, because in the extreme case we may have to divide the given array into exactly one array. So in that case we just sum up all the elements, and that's our answer. While the left boundary is 0, that is the case when we have all zeros in our array. So we want to search our first integer from this low to this high, which satisfies our condition. So what is the condition? The condition is that we want to find the minimum integer, which is the maximum sum of all the subarrays which we have. How many subarrays? K subarrays. So let's run the binary search, calculate the middle value. So for this mid, I'm guessing, okay, let's say mid is that answer. Mid is the required sum. So here this is the isValid function which divides the given array into k subarrays in such a way, which divides the given array into k subarrays and checks if we can find a possible partition where the sum of any sub array do not exceed this mid. If we can find such partition, then the answer lies in this range from low to mid minus 1. The answer is either mid, or it lies in this range. That's why I am initializing answer with this mid variable. Find the search space is reduced to this. Otherwise, if we can't do so, if we cannot partition our array into k subarrays such that the maximum sum of the subarrays does not exceed mid, if it is not the case, then we move to the second half range of the given array, that is from mid plus 1 to high. Why? Because our answer lies in this range only. Finally at the end we return the answer which we have calculated here. So how this isValid function is working, let's see that. Okay, so this is the definition of isValid function, which takes in the given array, the number of partitions that we have to make, the mid, this is the value which we have guessed. So we are guessing that, okay, mid is basically the required sum that we need. So this is the groups basically represents the number of partitions that we have done. This represents the answer. So we do not require this because this is a boolean function. So here we calculate the length of the given array, and now we traverse over the given array A, and here we check. We are checking if any integer in the given array is greater than mid. If it is the case, then we return false right from here. Why? Because let's say we find an integer x in the given array which exceeds the mid. So if it exceeds the mid, then even if we take this integer as an entire separate array, still we are not able to find the sum which is less than or equal to mid, because x is already greater than mid. Hence we return false. That is, we can't find a subarray, we can't find a partition where the maximum sum of all the subarrays does not exceed mid. It always exceeds mid because even a single integer is exceeding. Otherwise, here we are checking sum. Here we are adding this integer, the current integer, to the sum. If this sum exceeds the mid, then we have to make the partition. So what we are doing here, let's say we have a array 1, 2, 3, 4, this kind of array, and let's say the mid is 5. Now we start traversing the array from here. We find 1, we find 2, plus 1 plus 2 is 3, which is less than 5. Then we find 3. Now 3 plus 3 is going to give me 6. Now 6 is greater than 5. That means I have to divide the array right at this point. I can't divide the array here. I will have to divide it right here. So 1, 2 is separated as an array. We want to divide the subarrays such that the sum does not exceed this mid. So we start a new array from the next position. That's the logic here. Fine. That's what we are doing. If the sum exceeds the mid, then start a new group. Now start a new array and increment the number of partitions here. So groups basically represents the partitions, and reinitialize the sum to 0. And here we basically add the current number to the sum. I hope you're getting where we are going. I hope you're getting the definition of this function. Once you solve a few such problems, you will be able to come up with these predicate functions very easily. So finally, when we end this iteration, we get out of this loop, and here finally I check if the sum is greater than 0. So this is the case when we have some remaining elements at the end of the array, but we haven't encountered this condition while we were in the loop. So in that case, we check if we have such non-zero sum, then we have to partition, then we have to make a yet another partition for that group of elements. And hence finally, let's count if the group that we have divided the array into is less than or equal to k. If it is the case, then that means we return true, otherwise we return false. Why do we return true? Because we can divide the array into k sub arrays or less, such that the maximum sum of all those sub arrays does not exceed mid. And that means mid can be the potential answer. I'm not saying it is the answer, but it can be the answer. So we return true for this one. The answer would lie from low to mid. So I hope you got the idea where we are going. If you have any doubts in this, please make sure to comment down. I will try to reply it as soon as possible. Now let's discuss the time and space complexity for the implementation. Since we are performing a binary search, the binary search basically takes log of n, while the complexity of the predicate function or the boolean function is linear because we are traversing over the array. So the overall time complexity becomes n log n, while the space complexity is constant, as we are not using any extra space to store the we are not using any extra auxiliary space. So let's jump to the implementation part. So let's define the predicate function. So let's define the function minimize maximum sum which takes in the given array, let's call it nums, and the integer k. It returns an integer. Let's calculate the size of the nums array. Let's define the low pointer. The low pointer would be 0, while the high pointer is the sum of all the elements. So let's sum up all the elements which are present in the nums array and store that sum into the high. And let's declare another variable. Let's call it answer, which will store our final answer. Now let's perform the binary search. So calculate the middle element. Check if this middle is valid. So if it is valid, so is valid is basically the predicate function which we will define, k mid. So this predicate function is valid, checks if we can divide the nums array into k subarrays such that the maximum sum of all the subarrays do not exceed mid. And if we can do so, then that means mid can be the potential answer. So we store the mid into the answer array. So we store the mid into the answer, and we reinitialize our range. We have to search for the minimum answer, so the range goes from low to high. So the range goes from low to mid -1. Otherwise the range goes from mid +1 to high. So in this fashion the answer will be calculated, and at the end I will return the answer. So let's define the isValid function. So isValid function is basically a boolean function. It takes in the nums array, the integer k, and the mid, which is the sum. Let's define a variable sum which will be used to calculate the running sum. So let's start iterating over this array. Here I check if the current element which we have in the array, if the current element is greater than mid. If it is the case, then we return false right from here. Otherwise we check if there is a scope to perform a partition at this point. So if the sum exceeds the limit, which is mid, then we have to perform the partition. So let's take another variable to store the partitions or groups. So partition, let's call it partitions. So partitions will be incremented. Okay, and the sum will be reinitialized to 0 while we add the current integer into the sum here. Fine. So at the end I check if the partitions that I have made are less than equals to k. But before that I also have to check if we have a remaining group. If the sum is greater than 0, that means we haven't encountered this condition yet while we were into the loop, so we have to check it here. So if it is the case, then partitions increments by 1. Then we return this boolean right from here, which is if the partitions are less than equals to k, then we return true, otherwise we return false. Fine. So that's the implementation in C++. Let's see the implementation in other languages. Okay, so this is the implementation in Java. And this is the implementation in Python language. So that's all for this video. If you like this video, then hit the like button and make sure to subscribe to the YouTube channel. And continue in the binary search series. For more such problems will be in the upcoming videos. So for that, stay tuned with me. I hope to see you in my next videos.